Welcome back. This is Mr. Hassan's Maths channel, and I am now answering question number 8 from the January 2014 International A-Level IAL Mechanics M1 paper. This question here is about speed time graphs as two trains A and B start together from rest. Start at the same time, they both start from rest at time t equals 0 at a station and move along parallel straight horizontal tracks. Both trains come to rest at the next station after 180 seconds. So they both travel the same distance and they both come to rest at the same time, the next station. Train A moves with a constant acceleration 2/3 meters per second squared for 30 seconds and then moves at a constant speed for 120 seconds and then moves with constant deceleration for the final 30 seconds. Train B moves with constant acceleration for 90 seconds and then with constant deceleration for the final 90 seconds. Sketch on the same axes the speed time graphs for the motion of the two trains between the two stations. Okay, so we have to make a speed time graph, and on that speed time graph we have to have both journeys shown. Okay, so let me just get axes drawn. Okay, they're the axes, and so that's your speed and that's your time. Okay, so the time is in seconds and the speed is in meters per second. Okay, now for train A, it says it moves with constant acceleration of 2/3 meters per second squared for 30 seconds. Okay, so let's think about that. So you have 2/3 meters per second squared for 30 seconds. Let me just make a bit of space here and draw this a bit smaller so I can show some steps on the side of it. Okay, so basically it starts from rest, and we know that v equals u plus a times t. So the final speed it reaches is 0 plus the acceleration 2/3 times the time, which was for 30 seconds. So 2/3 times 30. So the final speed it reaches after it accelerates in that section is 2/3 times 30, which is 20 meters per second. And it takes, as we know, 30 seconds. All right, so that means after, let's say this is 30 seconds. After 30 seconds, it reaches a speed, let's say that's 20 meters per second over here. Okay, so you could show that part of the journey with a line that looks like this. Okay, and then it says it moves with constant speed for 120 seconds. So 120 seconds, so then that means it stops at 150, because 120 plus 30 is 150. So let's say that's 150. It's not to scale, just a sketch. So let's say that's 150 seconds. That's 120 seconds. It's going for that constant speed. Now there's 30 seconds left because it tells us that they get to the next station after 180 seconds. So that means the deceleration is going to be like a mirror image of the acceleration. It's going from 0 to 20 in 30 seconds. Here it's going from 20 to 0 in 30 seconds. So it's going to have the same gradient except the negative. Okay, so that's going to be the case here. So that's 180 seconds. And so that's for the A. Now, train B moves with constant acceleration for 90 seconds and then moves with constant deceleration for the final 90 seconds. So accelerates and then decelerates, and 90 seconds is exactly halfway. It's exactly halfway. So it's like a mirror image. So let's say it's going to go up like this. And then this will be identical to that, but negative gradient. Okay, so this has to go above here. It can't be below here because they have traveled the same distance. They're going from one station to the other, so they travel the same distance. So the area of this triangle and the area of this trapezium have to be the same. Okay, because they have the area under the speed time graph gives you the distance covered. Okay, so I can't draw this, you know, inside the trapezium because then the areas won't be the same. The area of this triangle and the trapezium must be the same. Okay, so that's a sketch of the speed time graphs of the motion for the motion of the two trains. I don't think we can put any more detail on there. So let's go to part B. It says find the acceleration of train B for the first half of its journey. Okay, so we want to find the acceleration of train B for the first half of its journey. Well, we know that it was train B. Train B is this one. It seemed a bit too easy there. This is train B, this is train A, right? This is train A, and this one is train B. Okay, so we want to find the acceleration. So we need to find the speed that it reaches. Okay, the top speed that it reaches, okay, which I'll call VB. We need to find that. If I find that, then I can say that that speed divided by that time, that's going to give me the acceleration. Okay, the gradient of this graph. So I need to know what that is. What I know about these two, as I just mentioned, is that the area of the trapezium and the area of the triangle are the same. Okay, so they have traveled the same distance in that time. Okay, so distance, therefore areas under graph are equal. Okay, so the area of the trapezium is equal to the area of the triangle. So I can say the area of this triangle, the area of the triangle is equal to the area of the trapezium. Okay, they're equal to each other. All right, so the triangle, its area is a half times base times height. And for the trapezium, its area is a half times A plus B times the height. Basically, the difference between the parallel sides divided by 2 times the sum of the parallel sides. So for the triangle, the base is 180, and the height is what we have to find, VB. Okay, so you're going to have a half times 180 times what we need to find, which will then give us the acceleration once we found it, and that's equal to the area of this trapezium. Now this trapezium, you have the parallel sides are these two. Okay, so the length from here to here is 180, and the length from here to there, well, that's 150 minus 30, which is 120. As I said, it goes for 120 seconds. We know that from the question. It tells us it goes for a constant speed for 120 seconds. So the sum of the parallel sides, so you have a half times the sum of the parallel sides, which are, as we mentioned, 120 plus 180. 120 plus 180 times the height, which is the difference between the parallel sides, which is 20, the distance between the parallel sides. So that's times 20. So that cancels with that, giving you 10. So you end up with that cancelling that, giving you 90. So we have 90 times VB is equal to, that's 300 times 10, that's 3,000. 120 plus 180 is 300 times 10, 3,000. So that means the velocity of B is going to be 3,000 divided by 90. So we have 3,000 divided by 90, which gives us 100 over 3. Okay, so we said the velocity of B is 100 over 3 meters per second. Meters per second. Okay, so that's the answer. That's not the final answer, by the way. That's the velocity of B. We have to find the acceleration. Now the acceleration, now I know this is 100 over 3. I'll leave it in this form. Okay, I can find the acceleration. The acceleration is the gradient of this line, which is 100 over 3 divided by 90. So we can say the acceleration is equal to 100 over 3. 100 over 3 divided by 90, which is 100 over 3 times 1 over 90, which is 100 over 270 meters per second squared. Let me write that in as a decimal form. Okay, so I have here calculator. I have 100 divided by 270. That gives me 10 over 27, of course, which is, okay, I'll leave it as 10 over 27. 10 over 27. Otherwise, I have to write it round. So acceleration is 10 over 27 meters per second squared. There's the answer to part B. So we've done A and B now. Now we've got to go on to part C. Okay. Okay, so part C says find the times when the two trains are moving at the same speed. Okay, when they're both moving at the same speed. Now they're moving at the same speed, okay, when they're both moving at 20 meters per second, basically. Okay, that's where they'll be moving at the same speed. Okay, so we're going to find the times when that is happening. So I need to find this time here. Okay, that's time 1. And I need to find this time here. And that's time 2. Okay, so that's when the speed is 20 meters per second. So we could find this out in a couple of ways. All right. One way we could do this is to work out, let's have a look for this one. What we could do is, well, I could use some sort of similarity here. Okay, because if you think about it, what I have here is a triangle. Okay, that's 90 over here. Okay, this triangle and this triangle are similar triangles. So let me just draw them out here. So I'll just make space down here. Okay, so I have this big triangle here. So this is like a big triangle. Let me just draw it quite big. Okay, this big triangle here. This is 90. Okay, half of this is like a big triangle. That's a half 90. And this is 100 over 3. Okay, and this is a triangle that's similar to that triangle because this is vertical, this is vertical. You know, this line is parallel to that. This angle is the same in both triangles. This angle is the same. So it's these two. So there's a smaller triangle inside that triangle which is similar. So we can use similarity. We want to find what T1 is, and we know that this is 20. We know that this is 20. Okay, so we can say here, using similarity, that T1 over 90 is equal to 20 divided by 100 over 3. So T1 is equal to 90 times 20 over 100 over 3. That's time 1. So we can work out what that is. So we have 90 multiplied by 20 over 100 over 3. Can you put this like that? No problem. And that gives us 54 seconds. That's 54 seconds. And we can see that there's a symmetry here. So if this is 54 seconds, then this must also be 54 seconds. Because it's symmetrical. They're both symmetrical. This is the same slope as this. This is but negative. And this is like, it's like a mirror image, line of symmetry here. Okay, so that must be 54 seconds. So time 2 is going to be 180 minus 54. So time 2 is going to be 180 minus that time. So it's 180, take away the answer, 54, which gives us 126 seconds. So that's time 1, and that's time 2. 54 seconds and 126 seconds. Okay, those are the two times when they're traveling at the same speed. That speed is 20 meters per second. There's probably another way of doing this. I mean, we know the acceleration here, so I could have actually found it by, and you know the acceleration here now. Okay, we've worked out the acceleration here, and we could use v equals u plus at. and we could find the time from that. V equals u plus at. Okay, so we know that v is 20, u is 0, a is what we found here. Did we find the acceleration? We had to find it, 10 over 27. So that's 10 over 27, and t is what we have to find. So you end up with t equals 27 times 20 over 10. Okay, which is 27 times 2, which is 54 seconds. So we could have used v equals u plus at. That's a simple way of doing it. I use similarity, but yeah, both of them are quite easy. But yeah, we could use the equation of motion because we know the acceleration. Okay, so I went a bit about it in a bit of a long way. But the second one, we could have used the symmetry. We should know this is symmetrical. So yeah, so I use similarity, but using v equals u plus at is probably better here. Okay, it's easier to do. All right, so that's where, you know the acceleration from part 1, you know the initial velocity is 0, you know the final velocity because it's at when they reach 20 meters per second, that's when they're going to be at the same speed, and you can find what t is there quite easily. And then this, you could also use equations of motion for this as well, okay, because you know that the initial speed here is 100 over 3, and the final speed is 20, and we want to find the time, and the acceleration is negative, that because we know it's symmetrical. So we could also use v equals u plus at, or the symmetry as I did before, but in either case we get the same answer. So I think doing it this way probably would have been quicker, but there's no problem. You can use a variety of methods, that's fine. Okay, now for part D, it says find the distance between the trains 96 seconds after they start. Okay, so let me just take this diagram again and put it down here. Okay, so 96 seconds after they start. So that's going to be somewhere over here. That's going to be somewhere over here. That's 90, so it's just past 90, so it's going to be over here. So we want to find the distance between the two trains. So basically we want to find the area of this trapezium here up to 96 seconds, and the area of this triangle plus this trapezium, okay, after 96 seconds. So like okay, so we have the area of this shape, okay, which is made up of a triangle and a trapezium, and the area of this trapezium up to there. The difference between the areas will be the distance between the two trains 96 seconds after they start. So we need to find the area of this trapezium that looks like this. This is for A. Okay, we know that this is 96 seconds, and we know that this is 96 minus 30. This is 96 minus 30, which is 66 up here, and we know this is 20. So we can say that the area, we can say that the distance traveled for A in 96 seconds is going to be the difference between the parallel sides, which is 20 over 2, times the sum of the parallel sides, which is 66 plus 96. So that's going to give me 10 times this value here. So you have 66 plus 96, which gives you 162. So you're going to end up with 1,600 and I just put the 100 down there. 1,620 meters. That's how far the first train has moved after 96 seconds. Now we got to also find for B. Now B is made up of basically this triangle shape, and you've also got this trapezium afterwards as well. Now the triangle is half the distance between the two stations. Okay, do we know the distance between the two stations? No, so we can just calculate anyway. That's 90, and that's 100 over 3. Okay, so you're going to have 90 times 100 over 3 times a half. That's a half times base of times height. That's the area of this part. Then you got the area of this trapezium part. So here you got 6 seconds here, and this is going to be, well, we have to work out what that is. Okay, we have to work out what that is. So we can use v equals u plus at to work out the time, from this section here. So we can say that if we take the initial velocity as 100 over 3, okay, taking the initial velocity here and the final velocity there, okay, we know the acceleration is negative because it's decelerating. It's negative 10 over 27. That the acceleration of this part is 10 over 27. That's going to be negative 10 over 27. It's decelerating. And we know the time is 6 seconds. And we want to find what the final speed is. That will give us the length of this parallel side. Okay, so we can say that v is equal to 100 over 3 plus minus 10 over 27 times 6. So that gives us what? We have 100 over 3 plus, we got minus 10 over 27. Whoops. Close the bracket. Open a new bracket. Times 6. Okay, so that gives us 280 over 9. 280 over 9. That's the speed at this point. So this is 280 over 9. So we can say that the area is going to be, let's just put this here now. This is the area of that first part plus the area of the second part, which is the distance between the parallel sides, which is 6 divided by 2, times the sum of the parallel side, which is 100 over 3 plus 280 over 9. And that should give us the distance traveled by B. This is for the area. So this is the distance for B is going to be all of this. So let's just stick this in our calculator and calculate it. So we have that's 45 times 100 over 3. Okay, and we got plus, that's 3 times, 6 over 2 is 3 times, I'll put it in brackets, I'll have 100 over 3 plus 2, is it 280? Yeah, 280 over 9. Plus 280 over 9. Can't read my own handwriting there. Be careful. Should be careful of that. 280 over 9, that was my last answer. That is going to give you the distance traveled by B, which is 5080 over 3. Okay, so 5080 over 3, which turns out to be 1693. So of course this is going to have traveled further. So therefore we can say that the distance between distance between A and B, distance between A and B is going to be 5080 over 3. Take away the distance that was traveled by A, which is 1620. So it's the answer we got. Take away 1620, and that gives us 220 over 3. 220 over 3 meters. And there's the answer to this question, which was part D. So there we have the answer to question number 8 from the M1 January 2014 IAL paper. Other questions from this particular paper can be found in the playlist that should appear in this area here. Other questions to do with kinematics, and I think I'll put a separate playlist for speed time graphs. Is going to be, or I'll call it travel graphs. I'll put that over here in this area over here, and you can subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.